workshop today on using Secret Network's IBC Developer Toolkit. So today on this DoraHacks workshop for HackSecret 5, you're going to learn how to use Secret Network's IBC Developer Toolkit so that you can be able to send encrypted payloads cross-chain from any IBC connected chain that has a transfer channel between that chain and Secret Network. And if you're new to working with IBC and that sounds like a lot of gobbledygook, have no fear. We're going to dive into what all that means today on this call. So before we go too far, I just want to shout out DoraHacks and HackSecret 5. This is our 5th official secret hackathon. It's live now. It's virtual. It's ongoing from February 1st to March 1st, and there are 15,000 USD in prizes. And there's multiple tracks. And we also are partnering with Autonomous to make this hackathon possible. So you can check out more info on the hackathon here at HackSecret5/detail. You can register on DoraHacks, and you can learn more about the hackathon tracks on the official DoraHacks page. The main things to note is that we have 4 tracks that you can apply for. One is using Autonomous's tech, their SDK. So you can learn about their AI framework here. They're also going to have a workshop tomorrow. If anyone wants to attend that, I highly recommend doing that. There is a track for using Secret AI SDK. So if you want to use Secret's AI toolkit, you can do that. We already had a workshop on that last week. So you can stream that on DoraHacks or on Binance. And there are cross-chain apps and apps that are built natively on Secret Network. So today, what you're going to be learning how to do is how to compete for this cross-chain dApps portion of the Secret Network hackathon tracks, and specifically using IBC. So we also have the ability on Secret to execute contracts cross-chain from EVM or from Solana using Secret Path or Axelar GMP. But today what we're learning is how to execute contracts on Secret cross-chain using IBC. So let us dive in. What we're looking at here is the Secret Network documentation, specifically the portion called the IBC Developer Toolkit. And I just want to give a quick shout out to Cromston, who's a community developer who is built on Secret Network. He was a big proponent in getting this off the ground. That's been an amazing part about building on Secret and in the Cosmos is if, everything's open source. If you're a community dev and you're building useful things, they will get used and you will improve the ecosystem. So what we're going to be looking at today is specifically cross-chain messaging with IBC hooks. And if you've never heard of IBC hooks before, it's an IBC middleware that uses token transfers to initiate smart contract calls. So the simplest way to think about this is that we're actually going to send a token transfer, an extremely small amount. And in sending that token transfer, we can add on additional data to the contract execution where we're actually able to call a smart contract on Secret. And so what we've done using IBC hooks is now when you initiate a token transfer, you can also execute contracts on Secret. And we've created this whole IBC developer toolkit where you can use contracts on Secret as a confidential computation layer for your chain. So any chain that you're on in the Cosmos, we're going to be using Osmosis today as the example. You can package your data, you can encrypt that data and store it in a secret contract and then be able to have unique query permissions to query that data in a secret contract. And the only requirements to be able to use the IBC developer toolkit is just that an IBC transfer channel exists between your chain and Secret. So for many mainnet chains, this already exists. We can just go to Mint Scan here and see the chains that are connected to Secret. So like all of these chains that we see listed here have transfer channels between them and Secret. So you could do all of this on mainnet, any of these chains. Yeah, lots of chains, right? And you can also do this yourself on testnet if you just establish a testnet transfer channel between your chain and Secret. So if we go into the Secret docs here, we see this tab here, IBC relaying with Go Relayer. And this teaches you how to use the Go relayer to set up a testnet transfer channel between neutron testnet and secret testnet. And you can apply these same principles to a different chain's testnet if you want to create your own transfer channel to be able to use for IBC relaying. But definitely check that out if you want to set up your own transfer channel. That's a little bit outside of the scope of what we're going to be learning today, but this all this documentation exists. So let's look at what you're actually going to be learning today. This is a full stack application that exists in Secret Networks docs. So if we go back to use cases here, we'll see we have some use cases like storing encrypted data on Secret Network, secret randomness with IBC hooks, confidential voting, sealed bid auctions. So this demo is linked in our docs here. That's what we're looking at. And we have 3 different demos in one all right here. We have storing encrypted data, confidential voting, and sealed bid auctions. And this is showing how to actually use what we're going to be learning today in a full stack application. So for example, all of this, right, at its core is storing encrypted data, confidential voting, and sealed bid auctions. These are just storing encrypted votes and encrypted bids in a secret contract. It's just showing a more like built out use case. So if we look at this, let's look at the voting example. So you can choose between Cosmos Hub or Osmosis. We're going to do this on Osmosis. I'm going to create a voting proposal, which is, are you submitting a project to HackSecret 5? All right, so the title is HackSecret 5. The description, are you submitting a project to HackSecret 5? And you'll see these are yes or no voting proposals where you can have encrypted votes. And you set an end time. Let's do 5 minutes. I'm going to create this proposal. Let's see. Approve this. Confirm the transaction. And you see like the fee is it's minimal, 0.001 Osmo. Approve. And if it's successful, we see that our transaction was returned, and we can actually view this transaction on MintScan. So let's check that out. Transaction success. We see that it was initiated from Osmosis, that our fee was 0.001 Osmo, and that the receiver was this secret contract. Let's see. Great. You see it use this transfer channel, channel 88. And let's see if our proposal has showed up yet in our contract. Not yet. All right, we'll come back to this. Let's just get started coding. So yeah, so this documentation all exists in the Secret Network IBC Developer Toolkit documentation. So you can see how to do all of this yourself. And you can learn how to clone down this repo here. This is the demo repo. And you can learn how to actually add your own mnemonic and utilize this so that you have it working locally. We're going to dig a little deeper today. We're going to actually just learn how to do the storing encrypted data portion of this, not connected to a front end, but just so you have a better understanding of how everything's actually working with the code, with the Secret Network smart contract, and also with the TypeScript SDK that we've developed. Does anyone have any questions so far before we start to dive a little further? All right, we keep chugging along. So let's see. This is what we're going to do. We're actually just going to follow along with the documentation exactly as it is here, so you feel empowered to do this yourself. So we're going to look at this key value store developer tutorial. And if you want to learn more just how the encryption actually works cross-chain, you can also check out Secret's docs. The kind of simple understanding is that it's done using SHA-20 poly 1305 with an additional AEAD algorithm. It's created using ECDH, and it's comprised of two main components, which is an extra encryption key, a public key provided from the secret gateway contract that we've already published on chain, and a randomly generated encryption private key on the user side that's independent of your actual wallet's private key. And using these keys in combination, we're able to encrypt the payload with SHA-20 poly 1305. So let's look at what that actually looks like on a contract level. So we're going to start with this key store value developer tutorial. We just looked at the mainnet tutorial. So the first step is just cloning down this repository here, Cosmos CCL SDK. And I've already done that on my machine locally. So you'll see I have that open here. The other thing is you need to configure the environment variables. So I already have this configured because I'm doing this on mainnet, so I'm not going to dox my keys, even though there's only $5. But if you look at the code that we have on GitHub, you'll see there's this inv.testnet. All that you would need to change to make this work for your wallet is update this file from inv.testnet to just .inv. Then that way the code will actually be able to access your files. And then you just add your mnemonic for Osmosis and for Secret. Because in this example, we're doing this on Secret mainnet and Osmosis mainnet. So that's all you would need to do is just add your mnemonic there and change this from inv.testnet to inv. Now, let us dive into the code. So, okay, the first step of this documentation is just compiling the contract and then uploading and instantiating the contract on Secret mainnet. I'm going to compile the contract, but then let's actually look at the code so you understand what the contract's doing. So let's just get the contract compiling because sometimes it takes a few seconds, but then we're going to look at the code itself. So I'm going to open up a terminal here, and I'm going to run that command, make build mainnet reproducible. Our contract is compiling. And now let's look at this contract. So this is the incredible thing about the IBC developer toolkit, okay? So you'll see in this code, there's two different contracts we're looking at. There's this gateway simple contract, which is what we're actually compiling right now and are going to instantiate on Secret mainnet. And then there's also this packages/SDK folder. And if you go into there, we see a source folder. And this is where like the actual implementation, the smart contract implementation of the SDK is built. So this is all of the stuff that has been abstracted away for you so that you can just use the SDK very simply and be able to store encrypted data on chain and cross chain, right? This is all this. All these types have been created. All the encryption schemas, everything is in here. And you don't need to touch any of that because your contract, gateway simple that we're creating today, it imports all of that logic and uses that for the encryption logic. So this contract that we're writing today, all that we're doing is storing a string in a secret contract. So we're able to pass an encrypted string cross-chain from any IBC chain to Secret. And if we look at this, it's very, very simple. We're going to start with just the state file. In here, we have a key map, which is a mapping of the user address who stores the string and then their secret string. That's all that this is. If we look at our message.rs file, we see we have two main methods, okay? We have inner methods and we have inner queries. And essentially all you need to know is that if you wanted to change this contract to make it, let's say you wanted to update this contract so that instead of just storing a string, you wanted to store an encrypted vote, then you would just create your store vote method. The method that you would actually want to add, you would just write in here and then update the logic in the contract to include that logic for that method. So what happens here is anything that's an inner method or an inner query, we wrap that using this gateway execute message and this gateway query message down here with these types. And that's where the SDK is actually doing all the magic behind the scenes. So if we were to open this up and take a look inside, we'd see that this is where the SDK is actually doing its work. So, and same thing for queries. The inner queries are wrapped using gateway query message. Okay. And then within that, that's where we have this encrypted variant of the enum, which takes these parameters: the payload, payload signature, payload hash, user key, and dots. So let's look at what that actually means. And then from there, let's just look at the contract. So you'll see when we instantiate the contract, all we do is we save an admin for the contract. And now let's look at where this encryption is happening in the contract logic. So you'll see right here, this is where all the magic happens. So in our execute function, we use the SDK right here with this handle encrypted wrapper. So we're importing this from the SDK, and that's where it's actually handling the encryption. So if we open this up, we can see that this function is where all the encryption, the cha-cha-poly encryption, is actually happening, okay? So again, this is all just boilerplate code. You wouldn't need to actually change any of that because this is already established in your execute message. All that you need to change to use the IBC SDK is your inner methods function. So right, like in this example, we have inner methods store secret, where we're storing a string. And then all that we're doing is we're importing that key map secrets from state.rs, and in it, we are saving the encrypted text and the user's wallet address that we're associating with that text, and then returning a default response, okay? So simple. So if you wanted to make this for private voting, for example, and actually just for the sake of understanding this better, let's actually just look at what the voting contract function looks like. You'll see that it's exactly the same. The only difference is that instead of a store secret method or store secret variant, we have a store vote. So let's just look at that so you understand. I'm gonna open up another tab. Let's see. Contracts. So here's the secret voting contract. And if we look at message, you'll see instead of now we just have a vote inner method and a create proposal, right? Very simple. Instead of store string, it's create proposal and it's vote. And then if we look at the contract, we go in, we see this looks exactly the same. We have an admin that we save. We use this, we import the SDK here with the handle encrypted wrapper, which is where all the encryption magic happens. And then here with the extension for the inner methods, we have create proposal and we have vote. And instead of just storing a string, we have a little bit more contract logic where we just have the logic for creating the proposal and for creating the vote here. All right. So hopefully you're starting to understand the magic of this SDK. But now let's look at how we actually instantiate this contract and use it on chain. And I think the only other thing we should look at before we do that is just the query functionality. So there's two different query ways that the SDK is designed. You can query with a query permit, which is a unique query operation to Secret Network, or you can query with auth data, which is a method that is more widely used across the Cosmos. But so you have two different options here, with permit or with auth data. I think in this scenario we're using with auth data. Let's see. Okay, yeah, so both are defined. And then I think the one that we actually end up using in our TypeScript code is with auth data, but we'll take a look at in a moment here. So we see that our contract was compiled successfully. Let's see where that was out. It was outputted here in this optimized WASM folder, gateway simple.wasm.gz. Now, let's go back to the documentation. So in order to upload this code, we need to compile the TypeScript files so that we can execute them. So like that's how we're actually going to execute the story and the string script, as well as the script to upload and instantiate the contract on Secret Network. So we compile the TypeScript files with this command npm run build. Let's actually look at the TypeScript code real quick. So all the TypeScript code is here in this source folder. So for example, we're going to end up using this deploy script to deploy and instantiate the contract on Secret Network that we're going to be using to store the encrypted string. So all that happens when we run this command npm run build is it just compiles this TypeScript code into JS that we're going to actually use. So let's do that. What's it saying? Command not found. Maybe I missed a step. Oh, I just have to install the dependencies. Right. So I'm going to run npm install. That way we're installing all the dependencies here in package JSON, like TypeScript. Okay. And then if we run npm run build, what it should do is just compile all this for us. Okay. And then it outputs all of the TypeScript SDK into this dist folder. And now that these are all JS files. And then that's where we're actually going to be doing this deploying. So you see here, all that it's doing is just reading the compiled WASM script that we just put an optimized WASM here. And then it's going to upload and instantiate that contract on Secret Network mainnet. That's what we have here with the Secret Network client. So let's do that. So once we compile the TypeScript files, we can run node dist/deploy. Let's see if this works. We're getting invalid JSON. I'm curious, let's just try a different RPC, a different URL here. Let's try, so we're going to use a different endpoint. I'm going back to the Secret Network documentation, going to this deployment addresses and API endpoints, connecting to the network. So I think what we actually want is like one of these LCD endpoints. Let's try this again. So I'm copying this, replacing this. We're waiting for this upload script to run and this deploy.js. Let's see what happens here. Does anyone have any questions in the meantime while we're waiting on this transaction to execute? All right, this is promising. Beautiful. All right, so now we have our code ID, our contract hash, and our contract address returned. And so for anyone who's watching this back on the stream, we had to make one adjustment here, which was just updating the URL here for our deploy script to use a different LCD URL for deploying to Secret Network mainnet. And all of that can be found in the docs under the API endpoints. Okay. So we now have the key value stored contract instantiated on Secret Network testnet. We just have to update contracts.json to actually point to this in our TypeScript SDK. So if we go back to the code, what we'll see here is, I think it's in this, where is this? Configs folder. So in configs, contracts.json, this is where we make sure that we replace this address with our address. So like that, and use this contract hash like that. There you go. And now we have a contract instantiated and we've updated our TypeScript SDK to point to that new contract. So we should actually be able to use this code. Let's try it out. Let's try to store our first string cross-chain from Osmosis to secret mainnet. So what we're going to be doing is we're going to be executing this gateway. No, it's this deploy config execute gateway. This is the code we're actually going to be executing. And what's happening here is we're executing our smart contract, and then we are querying that smart contract to see the updated response. And we're actually doing this encrypted as well as unencrypted so that we can see both responses from the network. So here's where we send the encrypted version, and this is where we're sending the non-encrypted version. And so to use this encryption logic, like the SDK is just doing its work here, where we have to get the gateway encryption key for the ECDH encryption. We get the consumer wallet for actually signing the message. We get the client, the wallet address. We load the IBC config, which all of this, again here, everything is abstracted away here. You don't have to worry about any of this. And from there, we're able to just execute the contract. So let's see, where is this actually happening? So response, send IBC token, right? So this is where we're actually calling the contract. Response simple. See how we have response simple and we have response encrypted. So response simple, it's storing this unencrypted text. And response encrypted, it's storing this encrypted text. Okay. I hope that makes sense. So let's actually call this. I don't think there's anything else we need to do. The main thing is that I just want to make sure you understand we're storing an unencrypted text and an encrypted text, and that you can also update this for your own functionality. So like, for example, like if we were doing voting instead, if we had just instantiated the voting contract, instead of calling store secret here, we would just be calling that create vote method. That's the only difference. And then we would pass the parameters for the vote. So let's do that. Let's call this. And this kind of just, the documentation walks through the code more as well. So you'll see like what it does. What it actually is doing is it's initiating a token transfer because we're using IBC hook. So it's through sending this token transfer that we're actually calling the contract that we just instantiated on Secret Network. And then we're going to get an IBC acknowledgement response. And then we can actually look at this on MintScan. And if you want to dive deeper into how the encryption SDK is actually working, all of that is documented here as well, just for anybody who's listening. So let's try calling this function. So this is the first unencrypted transfer. Let's pull up this transaction hash into MintScan. All right, looks like it was successful. And then this next one is the encrypted. So let's just go to MintScan to see what that looks like. I'm trying to see where we actually see the message that was received. So you can see the unencrypted message. So here. Basic acknowledgement. So you see all the IBC info here on MintScan. I'm just trying to see where I can find the actual, here we go. So here's where we actually called the method store secret, and then we see the string, right? So this is the unencrypted version. We called the method store secret. We see the text that we sent cross-chain, and that happened successfully, right? That was stored in our contract, but we didn't use the encryption variant. And so we just passed it unencrypted cross-chain as this right here, this new text. If you go back to the logic, that was this right here, this new text variable, okay? Then when we send the authenticated and encrypted message, we have this new text. And that's what we're actually encrypting cross-chain. So let's look at that on MITScan. Let's see where this was. So if we go back to our code, we'll see we have another transaction hash, and this is for the encrypted transaction. Let's grab that. And search that. All right, now we're looking at the encrypted transaction. Go to the event logs. Let's see if we can find. So zoomed in on my screen, it's hard for me to see this, but I want to make sure you guys see who are watching. Okay. I think it's here. Is it here? Here we go. All right, I think this is it. So now, here we go. Look. So before, right, where we could see the text that was actually being encrypted or being unencrypted, but just sent cross-chain. Now, everything is encrypted. So beautiful. And we also pass these additional parameters like payload signature, payload hash, payload, user key, nonce, and that's all used for our secret contract to be able to decrypt the contract on the secret side. So beautiful. Okay, that is the gist. I hope this is exciting for you. I hope that what you're understanding is that using this secret network CCL IBC developer toolkit, you can send cross-chain strings, anything you can imagine, cross-chain, encrypt it from any IBC chain that has a transfer channel between that chain and secret. So it kind of just opens up all these possibilities for being able to store encrypted data on your chain. And the way your users experience it is that they never even have to know that they're interacting with a secret contract. All of the transactions are happening on your chain of choice. Today we were looking at Osmosis. And if you want to do this for a chain where there currently does not have a transfer channel between secret network and your chain, you can learn how to create and relay your own transfer channel using the IBC relaying with Go Relayer documentation here in the secret docs. That concludes this tutorial. If you're watching this back and you have any questions, we have a very active developer Telegram group. It's called the Secret Network Community Developers on Telegram. Please join that. All of the links for anything that you could possibly need for this hackathon are all in Secret Network's DoraHacks for HackSecret 5. So you'll see the schedule for additional workshops. For example, tomorrow, our partner, Autonomous, is leading a live developer workshop on AI 3.0 infrastructure. Definitely come check that out. It's at 16 UTC. And there's all of these links to all of our documentation here, including the documentation we looked at today, such as confidential computation for IBC chains. So thank you, everybody, for watching. I hope this was informative. I hope you learned something, and I hope you have new questions that our community developers can help answer on Telegram or Discord. Have a great rest of your week, and hope to see you at future Secret Network programming. Thanks so much.